The secondary structure of proteins to a degree. So the secondary structure of proteins consists of regions of ordered structure adopted by the protein chain. In structural proteins such as wool, silk, the secondary structures are extensive and determine the overall shape and properties of such proteins. However, there are also regions of secondary structure in most other proteins. There are three main secondary structures. The alpha helix results from coiling of protein chains such that the peptide bonds make up the backbone are able to form hydrogen bonds between each other. These hydrogen bonds are directed along the axis of the helix. The side chains of the component amino acids stick out at right angles from the helix, thus minimizing steric interactions and further stabilizing the structure. Other less common types of helices can occur in proteins such as the 3-10 helix, which is more stretched than the ideal alpha helix, and the pi helix, which is much more compact and extremely rare. We also have the beta pleated sheet. The beta pleated sheet is a layering of protein chains, one on top of the other. Here too, the structure is held together by hydrogen bonds between the peptide bonds. The peptide chains, I mean. The side chains are situated at right angles to the sheets, once again to reduce the steric hindrance. And the chains in beta sheets can run in opposite directions, anti-parallel, or in the same direction, parallel. And the beta turn. A beta turn allows a polypeptide chain to turn abruptly and go in the opposite direction. This is important in allowing the protein to adopt a more globular, compact shape. Hydrogen bonding interaction between the first and third peptide bond of the turn is important in stabilizing the turn. Less abrupt changes in the direction of the polypeptide chain can also take place through longer loops, which are less regular in their structure but often rigid and well defined.